Hello, my name is Scott Covert. I've been developing on the Salesforce platform since 2010, and I help co-organize the Salesforce Developer Meetup group in DC. Today I wanted to talk to you about building Angular apps inside of Salesforce. Before we get into it, I want to talk about the differences between a typical model view controller architecture and that of a single page application. So with MVC, your application essentially calls some backend server. The server renders a new HTML page and delivers that to the client, resulting in a page refresh. With a single page application, your application interacts with a backend server via AJAX requests. So oftentimes there's some sort of a REST API involved. That server returns data, typically in JSON format, instead of returning markup. So what this means is the DOM refreshes without an actual page update. So again, the major difference here is with an MVC, the application routing is handled server-side, whereas with single-page applications, client-side JavaScript is used for routing. And there's some benefits to utilizing this method. So first of all, you get kind of like a native app-like experience, almost like you were on a mobile phone, in that your page transitions will feel a lot more fluid. Another thing is your state is never stored in your DOM, which simplifies the logic of your application a lot. And having kind of a separation between your client and your server can make it very easy to replace either or. So by that I mean if your entire front end is making REST calls to your back end, if one day you decide to adopt a new front-end framework, there's no need to make a bunch of changes to your back-end logic, and vice versa. So if one day you move to your back-end to a different platform, as long as you expose similar REST endpoints, your front-end shouldn't need to change. There are some disadvantages though too. So obviously, a single-page application, since all routing is done via JavaScript, a single-page application requires a client-side browser to be running JavaScript. You know, if you have a user that has JavaScript disabled on either their phone or browser, your application just straight up won't work. Another disadvantage can be search engine optimization. Due to the nature of how spiders and Google crawlers operate, a single endpoint can negatively impact your web app's search engine optimization. There are some Angular plugins for handling this and improving SEO, but it's just something to keep in mind. Another disadvantage can be intellectual property and security of your code. So given that your application's logic is written in JavaScript, it's accessible client-side by definition. So with a single-page application, you should always obfuscate your code, first off, by using things like uglifiers in your development workflow. But obviously, even with that, your logic is going to be available to the client. So it's best to also, don't store any keys or anything like that inside your front-end logic. Ensure that any access to back-end applications is only possible after some sort of user authentication. Okay, so let's start talking about Angular itself. So basically, AngularJS is a very popular JavaScript framework for building single-page applications. It provides bi-directional data binding to its view templates, and this is done through double angle brackets in the syntax, which we'll see later on, and those double angle brackets are kind of what gave it its name, AngularJS. It is a complete client-side solution, and it's built with CRUD applications in mind. CRUD being create, read, update, delete. So it can work very well with Salesforce applications, which oftentimes have the same CRUD requirements. Okay, so this is a a non-comprehensive list of some of the major components that make up an Angular app. The DOM is generated by using HTML templates and adding in data that's stored in Angular scope. So oftentimes the data is fetched from a backend using services that perform REST API calls, sometimes asynchronous, sometimes synchronous. And then Angular uses controllers to serve as kind of the glue for adding and responding to DOM events, rendering templates, keeping views and models in sync. I want to pause right there just to mention that the discussion today will be covering Angular 1. As some of you may know, controllers are going away with Angular 2. But given that Angular 2 is still in a beta state, I want to focus our discussion today to Angular 1. Okay, so Angular also offers the ability to create new HTML constructs called directives for grouping HTML into reusable components. These are really powerful. So kind of converting to Salesforce speak, you can think of these as similar to what Salesforce is doing with Lightning components. So directives are meant to be context agnostic, reusable code so that you can kind of write your logic once and keep from repeating yourself over and over again by just reusing those directives. And it should make maintenance of your code much easier and debugging easier as well. Okay, so there are a lot of benefits to implementing AngularJS when building a single-page application. Again, like I mentioned, there's two-way data binding, so changes to the view are immediately reflected in your model and vice versa. Another big leg up is it has a massive community online, and there are a lot of GitHub repositories out there. So given its explosion over the past few years, there are tons of open sourced Angular plugins and plenty of developers and forums to seek help from if you get lost. Dependency injection is another concept handled very well with Angular. This simplifies testing when drawing from multiple submodules or other open source projects that you've built into your code. Being a JavaScript framework, there are also a lot of popular developer tools like NPM, Bower, Grunt, Gulp, etc. That you can use now to streamline your build process. So this is great because now you're able to leverage a lot of tools that typically are only available to generic web developers and not necessarily Salesforce developers. But now you can really leverage a lot of these things like Chrome dev tools for debugging JavaScript. And we'll go over a few others later on. But basically, these can all greatly reduce time spent troubleshooting and developing. So this is just a picture to show kind of bidirectional data binding and what it means. Basically, you have your template used to construct a view that users actually interact with. They then make a change to this view and it updates the model. And there might be some business logic performed in the model that then causes changes in other places to the view, which are automatically updated. So you have kind of these continuous updates where the model is the single source of truth. Angular is a really great front-end framework, but it's definitely not without its faults. One thing a lot of people say is it's quite opinionated as frameworks go. If you're out seeking help on the forums, you might run across a lot of developers mentioning the quote Angular way of doing things. Another problem some people claim Angular has is it can be a bit esoteric. And a lot of people point to the double angle brackets, the ng attributes, which we'll come across later, as being a bit niche in terms of the syntax. And a lot of people would prefer to learn something that could apply to future frameworks down the road. Another thing to keep in mind, a lot of people point to Angular having a very interesting learning curve with a lot of highs and lows. But I can say that, in my personal experience, I would say the pros outweigh the cons. So I would definitely take some time to learn at least the basics. Okay, so here's just a sample Angular apps template. Basically, a lot of it you can see looks like basic HTML with a few caveats. So here we can see we're setting the Angular app to be PhoneCat app. Down below, we'll see some HTML attributes we're probably not familiar with. ng model for storing into our controller scope whatever value is in this HTML node, this input node, we're going to store against the query variable. And we can also see this custom attribute ng repeat, which is essentially an iterator in the Angular world. And here's those double angle brackets I was talking about. So this means that we have bidirectional data binding on phone.name within this specific span. Similar with the phone.snippet here. And here's an example of a controller. In fact, the controller that matches the template we were just looking at. So we can see here we've defined the PhoneCat app module, and we're giving it a controller that populates all this data. Now, typically, again, this would be done by hitting some sort of a backend server to populate phones, but we're just hard coding it in here, an array of objects. We're giving each phone a name, a snippet, and an age. Okay, so let's take a look at a sample Angular app. As you can see here, this is basically the app that we had just built, where we list out all the different phones and we provide on the front end a search. So if I want to only return results for, let's say, Nexus phones, then we can filter our list that way. Okay, so that's all well and good, but being Salesforce developers, we'd like to see how we can take the Angular front-end framework and put it into Salesforce terms. So first of all, Angular apps are basically served up through static resources to a standard Visualforce page. The HTML templates that serve as the Angular templates can be stored either in individual Visualforce pages themselves, or if we want to modularize as much as possible, we can put them into component fragments as well. The actual backend logic that performs CRUD operations can be Apex methods that are annotated with the remote action method to make them available to JavaScript. And that way data can easily be fetched from the Salesforce backend through Angular services that call out asynchronously to those Apex methods. A popular library that a lot of people use is Kevin Portman's ngForce. It's a great starting point and includes a lot of basic Salesforce CRUD services just already wrapped up and created for you. In addition to the standard services included in ngForce, Visualforce remoting can be used to fetch data and trigger custom business logic through your services. And JSForce is another good library for accessing the Salesforce API if you're building Angular apps that are to be hosted in the cloud rather than inside of Salesforce. Okay, so there are a lot of benefits to connecting Angular and Salesforce1. One of those being the live refresh ability when you're initially developing your code or debugging and troubleshooting issues. So Daniel Nakov gave a talk I believe Dreamforce 2014, about a Chrome extension he built called Proxily. And this kind of goes into what I was talking about before about the ability to use kind of more generic web developer tools when building out your Angular Salesforce apps. So what Proxily does is it allows you to tell Chrome to redirect callouts to certain URLs to local resources. And since we're serving all of our Angular JavaScript code through a static resource, we can build a redirect to that any calls to that static resource to go instead to our local machine. So this means you can basically code your application much faster because you can make changes locally and your browser will refresh instantly without waiting for Salesforce's server to recompile the code. And then once you're happy, you can use I like to do all my Apex development and Salesforce development in Sublime Text using Maven's Mate, which has the ability to zip and unzip static resources really easily. So what you can do when you're done using developing your Angular app and happy with the way everything looks when it's running locally, you just can use Maven's Mate to zip up all those files and send that new static resource to the Salesforce server. In many cases, also when building Angular apps in Salesforce, you'll find your Angular controller handles the view logic, or possibly even your Angular directives handle all the logic, while your Apex classes really only handle business logic and CRUD-based functions. This really simplifies your Apex methods and thus testing of those methods as well when it comes time to write your Apex unit tests. So that kind of separation of concerns that we were talking about before really pays off as you continue to build and grow your application. Again, having so much of your app's logic stored in JavaScript rather than Apex and Visualforce allows you to leverage numerous web developer debugging tools, like I just mentioned, Proxily, but also just the generic Chrome dev tools, as well as plenty others out there. Many UI frameworks play nicely with Angular, like Bootstrap. Ionic is a framework actually built on top of Angular and Cordova. And this means you can really easily build like a Salesforce1 mobile-ready application right out of the gates. You can also obviously utilize the new Salesforce Lightning Design UI framework, which is really cool. So lots of good stuff. I just want to mention this presentation is available on my GitHub page to be downloaded and run locally. You can also run it through GitHub IO. And before we close out, I would just like to go over a live demo, show you how this kind of looks, how an Angular app running inside of Salesforce looks, and show you some of the code behind it. So let's go ahead and take a look at that. Okay, so this is a really basic application that basically just lists out records. In this case, these are all the account records. And similar to what we were doing with the phones before, we can go ahead and filter down to just show specific ones if we want. Now, just to give an example of the routing, this is all, as you'll see, on this default home Visualforce page. And if I go ahead and hit the second button, I'll be routed now to view contacts. Now, there was a refresh in terms of the data on the page, but if I go back and look at my URL, I'm still at this same Visualforce page. And now, all my logic will filter down the the contacts rather than accounts. So I just want to go over some of the code that powers this. Okay, this is our main Angular app. All it really has here is routing information. We tell it, what template to use, and we'll go over this further in a moment, but basically it's using a default home accounts Visualforce page for the account view, and for the contact view it's using a separate Visualforce page called default home contacts. It also tells the application what Angular controller should be used for each of the different views. Now in this case I've centralized all logic into a single controller, but you can create totally different controllers for all of your different views if need be. And this right here is actually just logic for setting up config options for that spinning loader that we saw when we were refreshing data from the server. So here's that centralized controller. Basically all it does is it does a call out to the Salesforce backend to get its records and populates an Angular scope variable called records with its results. Then after 2 seconds, it'll stop the spinner. So we go ahead and start the spinner when we're about to perform the call out, get the results, and then stop the spinner. Here's the Angular service where the call out to our Salesforce server is actually performed. And this will look familiar to anyone who's used Visualforce remoting before, right? So in this function, I take in a parameter record type, and then I use that to populate the action that I'm going to perform for my Visualforce remoting. In this case, I'm going to call my default controller Apex class, and the specific method I'll be called will be get plus whatever the record type is. So let's go ahead and take a look now at the Visualforce code that's powering this. So here is our default homepage. Now this looks like a lot at first, I understand, but keep in mind all this is really doing is pulling in the JavaScript libraries that our app depends on. And there are also a lot of great dev tools, generators like Yeoman, things like that can automate some of this for you in terms of adding the script loads when you add a new dependency to your application. But basically, logic-wise, all we're really doing here is telling the body of the page to be equal to our Angular's view. And then then what basically happens is our controller is used to populate that ng view. The routing is used to populate that ng view. So this is where we get into, okay, so if the URL is blank by default, then we're just going to use the default home accounts view. If we are looking specifically at contacts, we're going to use default home contacts. So if I go back here, you can see now this is where the route provider comes in. We can see that we're set to contacts. If we were to change this, we would go back to the account view. Okay, so let's take a look at those Visualforce pages: default home accounts, default home contacts. These can be used as essentially templates. Sort of like your Angular templates. You can create a different Visualforce page for all your different views. And Salesforce already has some templating constructs built into it, right, through Visualforce components. So you can see here, both my default home accounts and default home contacts Visualforce pages really only draw upon a single Visualforce component and just pass in the record type that's being set. And this record type, again, back in our routing logic, we tell it, okay, for accounts, the record type is accounts, and for contacts, the contacts view, the record type is contacts. But you could imagine you might want to have some account-specific UI elements in your DOM when you have the accounts view, so that you can create different templates for that. Here is the Visualforce component that is being used by both of our views, and this is what actually shows, the search layout, for example, and the iteration over all the records returned from the backend and the list that's actually showed to the user. One thing before we wrap up, one final thing I want to show is that Proxly extension that I'd spoken about before that can make development really cool. So if I go back here, You can see I have this plugin, and basically what it's saying is, okay, I want to redirect any calls to this default static resource um, to my local machine, right? And another thing that's great about this is it offers live reload. So as I change my Angular logic, the page will automatically refresh. So let's go ahead and see that setup. So here's my Proxy settings. I'm just basically saying, okay, I've given it some regex to just say, okay, anytime I'm doing a call out to the default static resource, I want to strip off all of that so that way it will point to my local machine and see this is the local directory that it's actually going to be going to. Okay, cool. So let's go ahead and see this in person now. And just to just to warn you, obviously this means that you won't have HTTPS enabled for the page. Chrome might give you a warning about that, in which case a little shield should appear here, and you can say load unsafe scripts because you're really just loading your own local scripts. So it should be fine. I'm going to go ahead and open the Chrome DevTools, and let's change our controller to also spit out our records to the console. Now when I save this, the page should automatically refresh, and you can see it refreshing right now. And here you can see that the logic has actually changed. Here's all the records returned by the query logged in the console. Very cool. Well, again, all of the code that you've seen here is on my GitHub page, in addition to the presentation itself. Thank you very much for joining me to learn about Angular and Salesforce.